I do have some things to show you that actually worked. This is making a big deal. There's a secret management interface and Intel chips that gives remote control to them, and people have figured out how to use it to hack into the machines. There is no way to turn it off. Nobody knew about it until recently. It's in all Intel devices. And there's a San Francisco startup that is promising they are going to figure some way to remove this from your devices, which would be a pretty desirable feature. Let me just get rid of these things. Oh, I won't probably get rid of now, but I'm in use. Anyway, so that's a fun fact. And this one is pretty amazing. This is remote entanglement. The whole point of quantum computers is you have to have qubits, which are electrons or atoms or photons or something in a state of uncertainty, where it has some probability of being 1 and some probability of being 0. And then you have several of these things entangled together, which is a quantum mechanical association, so one of them affects the state of the other. That is what you need to do quantum computations, which are almost like magic, where you get to an answer without going through all the steps leading to the answer. And until recently, that has only been possible at close range. So these guys have figured out how to do it with two things that are connected by about 30 yards of optical fiber. And they say they can easily scale that up to kilometers. And if that's true, then they can make a quantum internet where quantum information is sent long distances over a quantum internet, which would make large-scale distributed quantum computing possible. So every week, there's another big step forward in this quantum stuff, and that's why the NSA warned us that all the current public cryptography systems are on the way out. Because when quantum computers really work, which is obviously coming very soon, then all of our current hard problems will stop being hard. And that will mean we need new quantum-resistant computation method, encryption methods, and those don't exist yet, but people are working on them. Anyway, I think it's time to start the next chapter here, which is wireless. So let me bring it up. There we are. All right. So let's go to the start. Okay. All right. So we're going to talk about wireless networks, and the point is to explain how wireless networks work, and then the security problems of wireless networks, which are, of course, quite large. The wireless networks were at first difficult to sell to consumers because average consumers could just take a look at it and say, this can't be right. My data is just going everywhere all around me. I don't even know who's connected to it. That's got to be more dangerous than putting it in a wire, and indeed it is. So there's a lot of wireless technology out there, almost all of it crammed in the same small band near 2.5 gigahertz. Most of the frequency spectrum was reserved by law for commercial products and for the military and for such, and only a small portion was available for general use. So almost all these devices are running on the same frequency range, giving all the interference. But for wireless data network, the protocol called Wi-Fi, which is what we most directly use in computing, you have this structure. You have an access point and a wireless network card. Then it connects to a wired network somewhere because you need a wired network to carry data a long distance. The Wi-Fi that we use has a maximum range of about 100 yards. It's really what radio people call line of sight, which is a kind of vague term. That means if you're out in an open field, it's about as far as you can see easily. But if you're in a place with forest or trees or buildings, then those things get in the way and it's cut down a lot. Anyway, so you have a, let me see if I can get this thing off my screen. Okay. All right, so the access point is the transducer that sends and receives radio signals and then translates it into some kind of wired networking, typically Ethernet. And so it's only broadcasting a signal. If you have a typical home Wi-Fi, it's limited to very low power. I think it's 100 milliwatts is what you can emit in America without a ham radio license. This is why anybody that gets serious about wireless networking and hacking needs to get a ham radio license, because then you can put out signals that are much stronger and do much more interesting things. Anyway, so your wireless network broadcasts its service set identifier. If you look at the wireless networks here, there's only 5 or 6 of them. If I go to a coffee house, there's more like 50 or 60. These are all sharing the same channels typically. And so every device can receive them all. So these are what's called the SSID. This is the name of the network transmitted in plain text with every packet. And that is what's used to pay attention to that channel. So everything you send is being picked up by all the wireless devices around you, but they are ignoring everything that's not on the channel they're associated with, because that's all they care about. Unless, of course, they're a hacker and they run in monitor mode, in which case they collect everything, including the stuff that's not addressed to them. which you can do if you have the right hardware and software. So the server set identifier is the name used to identify the network. That's this alphabetic name, something like CCSF Wi-Fi. And you'll see it in this list. You typically configure your access point to broadcast this. It is possible to turn off the broadcasts, and some people recommend it for security. This is a very expensive way to achieve security. It cuts down the value of the network quite a bit. If you are a home user and you have only one access point, then the only problem is you're now going to have to, every time you connect a new device, you're going to have to type in the name. But if you're in an enterprise network like we have here, where we have hundreds of access points all over campus, the broadcasts are what your computer uses to tell when you're moving from one location to another. As you move to another room, the signal from this access point will get weaker, the signal from the other one will get stronger, and when the broadcasts from the new one are stronger than the broadcast from the old one, your machine will disconnect from this one and connect to that one silently. As you know, your cell phone does the same thing. You walk around your cell phone. If you wander out of the range of one tower, it'll let go of that tower and connect to the other tower without interrupting your call. And Wi-Fi can do the same thing, but only if you don't block the broadcasts. If you block the broadcasts, you cannot do roaming anymore because you do not have any measure of how strong the signal is. A lot of problems with Wi-Fi come from the fact that the signal strength varies greatly. Signal strength falls off as the inverse square of the distance from the antenna, so the signal strength varies by a factor of 10 or 100. And a lot of things like collision detection in Ethernet rely on knowing what the signal strength should be and detecting when the signal strength is an unusual value, and you cannot do that in Wi-Fi. The signal strength is wildly varying from the intrinsic properties of the medium, so you can't conclude anything about measuring signal strength. All right, so many vendors manufacture devices called SSID like Netgear or Linksys, and most home equipment is very vulnerable. You attack all the time, and it's easier if people can tell what vendor it is. You can just look up attacks for each vendor. So one thing that's recommended is to change your SSID to something personal. This also helps you find the network among all your neighbors. You might have the same thing. We have various default SSIDs. So when you configure your access point, each manufacturer gives you a web-based configuration that is random for each one. They always have the same options, but they just rearrange them on the pages however the manufacturer felt like rearranging them. Your home wireless router is actually several devices miniaturized and put in one box. It's a router, an access point, and a switch, and usually a firewall, all in one box. The enterprise class versions of those things would be separate units on the rack. But the home version is just a miniaturized combination of all of those. So you're going to have the ability to configure the SSID. So you can rename your network, like this one's named Cisco. You'll be able to choose what kind of encryption to use. Many devices speak WEP. WEP is very old and should be avoided whenever possible because it's very insecure. But there are some devices that date from a long time ago that speak only WEP. And you would have to use WEP if you want to be interoperating with those devices. All right, so a lot of people say turn off SSID broadcast, like rename the SSID. These are weak security measures, but you can do them. All right, you need to have a wireless NIC on every card. Almost everyone now has portable devices where it's built in, but there are desktops, so you'd have to add a component for it. And the only other thing to say about these is that a whole category of older wireless NICs is highly prized by hackers and always being sold at DEF CON because there are 4 actual modes for a wireless NIC. There's master, monitor, managed, and injection. And the only mode that a normal person ever wants is master, not master, but the one where it lets the master tell it what to do. Normally all you are is a client. The access point tells you what channel, what encryption, and managed. That's what it's called. Managed is the normal mode that a normal person uses. Master is for the access point. And normally a laptop has no reason to be a master. It's something hackers often want to do in order to put themselves in the middle. You do that with the Evil Twin attack. If you go to Starbucks, they have a network called something like Starbucks, and all you have to do is put in a network card that can achieve master mode and turn up your power until you're stronger than the real Starbucks, and all the devices in the room will disconnect from the real Starbucks and connect to you because their laptop will think someone has picked them up and moved them to another room, and they're closer to you now. And most operating systems, if not all, will also let you connect with a different mode of security, and they will not warn you. So you can be connected with WPA2, I can connect you with no encryption at all, and your device will continue to have your banking session and download and everything without telling you that. Right. And if you want to crack WEP, which is more of historical interest than anything else, since almost nobody uses WEP anymore, you have to be able to inject packets to do it efficiently. And that is where you, now monitor mode is where you receive packets that are not addressed to you. And injection mode is where you send out packets that lie and pretend to come from somebody else. And those have no legitimate purpose for a normal user, but they're quite useful for hackers attacking wireless networks. Although these days, they aren't really that useful for that either. Because the main thing you do is crack WEP, and WEP is pretty much over. So these things are standardized by the IEEE, just like all networking standards. Unfortunately, the IEEE is greatly dominated by vendors that move in and push their products, and they have a lot of internal fighting, so they've been paralyzed frequently. And they were paralyzed seriously over wireless security, which led to non-standard things becoming popular, which is not something that most electrical engineers like. You know, these plugs in the wall with 3 prongs have a certain specification of how long the prongs are and where they are, so all the devices can plug in and all the sockets are the same. That's the benefit of standards. But when the standards don't appear fast enough, manufacturers just start making stuff and selling them because there's money to be made, even though the standard doesn't exist yet. And all these committees can easily take too long to make up their mind. So 802.11 was the first wireless standard. 802 was networking in general. 802.11 was wireless networking. And originally it was very slow, 1 megabit per second or so. Now the problem is wireless networks, like I said, cannot detect collisions. The way Ethernet wired networks detect collisions is there are certain voltages you're supposed to see, like 0 and 5 volts. And if 2 packets sum together, you get something like 10 volts. So you can easily tell from the voltage that something has happened there, and you know there's been a collision. But in wireless networks, you can't do that at all. Because if the signal suddenly gets much stronger, it might just mean you moved closer to the antenna. Not that 2 things have collided. So you cannot use collision detection, so you have to do this, CSMA-CA, carrier sense multiple access collision avoidance, which means every time you speak on a wireless network, first send a clear to send saying, everybody shut up, I'm about to speak. Okay, here I speak, now I'm done, now you can talk, every single one of them. So the total amount of bandwidth available for transmission is less than half of the rated bandwidth. More than half of the actual data transmitted on a normal wireless network is in control signals, arguing, retransmitting things that got lost, deciding who's going to talk next, and so on. It's very messy, but it's very popular because people like to have portable devices. All right, so you call the addressable unit a station, and the basic architecture is called a basic service set, where you have an access point and you have the devices connected to that access point. That's called the basic service set, all the computers in the room. If you have a home router and you only have one router, this is all you have, one basic service set. If you're something like a company like City College, you have a distribution system between them, and you have many routers and many basic service sets connected to each other. And that creates the larger WLAN. Unfortunately, the frequency range is so narrow in America that there are actually only 3 non-overlapping channels, and non-overlapping is kind of a harsh statement. This means non-overlapping at 50% power. So you can really only use 1, 6, and 11 if you want to have even like 3/4 of the energy not overlapping, and these other channels in between overlap great. It's one of the reasons why you really would like to move up to 5 gigahertz. Anyway, that 2.4 gigahertz band is very crowded with other devices too, which is why the primary problem in wireless connection is almost always interference from other devices. It's usually not walls or trees or anything. Infrared would be another option. This is how most short-range remote controls like TV remote controls work. It's a lot more precise, much higher frequency. The problem is it doesn't go around corners. You have to point it directly at the device. If anything's in the way, it doesn't get through. So it's not used very much for any data transfer, except there used to be PDAs that would do infrared synchronizing over a few inches. And I think there's some devices that still do that, but it never got very popular. All right, so 802.11a was the first one created. It ran at 5 gigahertz, not this 2.4. It would have been a good idea, but it was relatively short range and it was very unpopular. Very few people used 802.11a. The one that was a big hit was 802.11b, even though it was slower. But this was back in the 90s, when even 11 megahertz sounded like more bandwidth than you'd ever have, and most people were using 56 kilobit internet connections anyway. So that's all you need. And this was the one that became a big commercial success. And as I said, even relatively non-scientific, non-technical people immediately were suspicious. This can't be right. Just sending my data by radio all over the room, that's got to be unsafe. So the industry created this thing called WEP, Wired Equivalent Privacy, which is a marketing term to promise to people you'll be as safe as if you used a wire. It was immediately debunked as an atrocious lie. Within a year of it coming out, it was completely hacked and proven that it doesn't detect you hardly at all. It's you can get in with no knowledge of the key. But there was no solution for 10 years. As the IEEE argued about it, so proprietary solutions appeared while the IEEE did not make up their mind about the official solution. So 802.11e was a small improvement to fix interference. 802.11g was the faster version of networks, going up to 54 megabits per second, still on 2.4 gigahertz. And 802.11i is what finally codified the industry thing called Wi-Fi protected access. And by the way, you can tell non-approved things from approved things by the acronyms. Wi-Fi stands for wireless fidelity, and Wi-Fi protected access is an acronym of an acronym. And academics would never let you do that. That's like mixing up verbs and participles, but industry marketing people couldn't care less. They had used language that would ever look prettier on the package. And since the IEEE did not approve this, but marketing people invented it, they had this strange acronym of an acronym. Anyway, that's WPA. WPA was a rush job to create a software update that could be put on web-enabled devices without adding any hardware to make them safer. So web was getting hacked, and there were 4 defects in web that made it possible to hack it. So they put small changes in web just to fix those 4 problems. And the point was, they thought it would probably make it harder to hack for a few years while everybody could replace that generation of devices with another generation of devices that was more powerful and could run a better encryption standard, WPA2. Yeah.
As far as Wi-Fi, what about like Wi-Fi?
Wi-Fi?
Yeah, it's like they use like light diodes.
Free space optics?
Yeah.
Free space optics is something people talk about. The problem is rain and fog and smoke get in the way. So it's pretty much a stunt, I think. I don't think I see it deployed very much. It might have its place. Another thing that I think is probably far more useful is power line networking to solve a very common problem when your home is too big and your Wi-Fi signal can't fill the home. Then you go through the power line to get from one room to another, so you don't have to drill holes in the wall. You don't get enormously high speed, and your data is in fact being shared with your neighbors probably, but there's encryption options, and that's a pretty good option for many people. Free space optics sounds good, but I haven't seen anybody actually deploy it. I think the problem with, depending on weather, is really pretty serious. Fiber optics, of course, is the simple solution to that. Then you have a cable, you bury it under the ground or hang it from a pole, and now the weather doesn't matter anymore. So, but it does exist, the free space optics, and some people think it's swell. Anyway, so 802.11n was the attempt to make something faster than 802.11g. And the point of this was something insane, although if you want insanity, you want to learn how DSL works. DSL is unbelievable. DSL takes every small piece of the waveform and puts data in it, even the phase, the amplitude, the frequency shift, to where it's crazy. And that's why it falls off so rapidly with distance from the carrier. 802.11n is similar. In 802.11n, you cram as much data as you can down a 2.5 gigahertz signal, so you put multiple antennas, and you have one beam that bounces off the roof, and one that bounces off the wall, and one that bounces off the floor, and you send a different data channel down these spatial paths. So to get full bandwidth, you have to have multiple antennas on the router and multiple antennas on the laptop. And then in software, it negotiates multiple spatial paths to send more data through. Yeah.
With 4 different streams, doesn't that mean 4 different sources of interference for their own message?
It would, of course, mean that you could pick up interference from anything that gets in, yes. It also is interesting in that your data will be following different paths. It's amazing it works at all, but the same thing's true of DSL. Very clever people said, how do we get more data through this signal? What else could be used? And you could use the spatial distribution of the wireless signal as a way to separate different channels, if you were determined enough. It's surprising that it works. And I haven't tested 802.11n enough to know how often you really get that 600. The equipment I've seen is rated more like 200 because I think it's not able to actually resolve those spatial channels. So the 802.11n, it looks like this. They have multiple antennas if you're going to get full bandwidth, and at least a couple of years ago, these things cost several $100 each for the NICs. 802.11ac is the next step up to a gigabit, and this uses wider channels. And I think it runs at, 5 gigahertz, that's why. 5 gigahertz and 2.4 gigahertz, and by the way, so does 802.11n. Use both of the frequency ranges also to get faster. And 802.11ac is built into the MacBook Air for the last several years. One thing about Apple hardware is you always have the latest of everything. And 802.11ad is the very latest, and this is the big step forward. The 100 gigahertz band has been a long-sought goal of electrical engineers. The problem with the 100 gigahertz band is until a few years ago, there was no silicon chips available that could generate or receive it that were cheap to make. And somebody solved that problem a few years ago, so you can now manufacture things up in the 100 gigahertz range. And a higher base frequency means you can move more data. So this one's up at 60 gigahertz, near 100, and it can go at 7,000 megabits per second. The problem is it only goes a short distance, like 30 feet, so they're not selling it as a way to move data from your computer to the router, but as a way to get all the cables off your desktop. So it will move the video signal from your monitor and the keyboard and everything. All your devices will connect on your desktop without cables. That's the immediate application of it. Yeah?
Is there a price for the little bin?
I don't know why they have all those goofy little antennas. I've seen boxes that don't have all those. I don't think it uses spatial channels, but I'm not sure. That's what the first thing I think is. It must be using spatial channels.
Yeah, the 3 antenna, and now it's the
yes.
Antenna, yeah.
And I don't know the details. I see it was $300. This was a couple years ago. I think it's cheaper now. So iPhone 8 will supposedly have the 802.11ad in it. I don't have one. Now people are getting the 10. Maybe some of you have it. But I don't know anybody that has the 802.11ad to provide it to you. But I guess if you put this thing in your home and you stayed within 30 feet of it, you could have even faster bandwidth. I remember when this stuff started coming out, when LTE came out, they said, you know, there's a problem because all it means is you can hit your monthly bandwidth cap at now 10 minutes of downloading instead of 30 minutes of downloading. But I think some plans are now getting rid of the bandwidth caps. That was the problem with the original iPhone. When the original iPhone came out, people started looking at videos and text and everything on their phone, and they started using up so much bandwidth that AT&T ran out of backbone bandwidth. So then they started making disincentives to make people not use their iPhone, which really, really, really bothered Steve Jobs. So I made this beautiful thing, and then you tell people not to use it. What is your problem? But I think now they've increased the backhaul to where there is enough bandwidth for all these intense, bandwidth-intense operations. So Europeans use something called HyperLAN, not compatible with 802.11. So that would be a drag. 802.15 is the standard for wireless personal area networks, which is the most popular one is Bluetooth, which you use to connect devices on your body, like the earphone to your phone and such. And this is 2.5 gigahertz again. The early version of it went 2 megabits per second, then it updated to 24 megabits per second. Bluetooth does have the ability to encrypt signals, and the encryption is fine as far as I know. The problem is an awful lot of cheap devices have it turned off, and they have the association pin hardwired to 0000, and you can't change it. So a lot of devices don't use the encryption. If you actually use a Bluetooth keyboard that is encrypted, it is safer than a non-wireless keyboard because wired keyboards emit radio. And you can pick it up to 100 feet away with an antenna and find out everything you're typing. So an encrypted wireless signal is actually safer because even though it can be easily picked up, it's encrypted. Anyway, 802.16 was WiMAX. This was a big push in America about 6 or 7 years ago. They went to many cities with WiMAX. I had a WiMAX phone. And I remember it hit San Francisco for like 1 week, and then they took it down. They gave up on WiMAX. WiMAX was a sort of political boondoggle. It only went to about 10 megabits per second in practice, although the standard supposedly would go to 100, and was rapidly wiped out by LTE. 802.1120 is a standard for moving cars and trains. So WiMAX rolled out and then rolled back. Sprint rolled it out, and then they canceled it and abandoned it in 2016. It only hit a few cities in America before they just gave up on it and abandoned it. And so I had a phone that was 4G that rapidly became a 3G. LTE is what replaced it. LTE is got to be one of those meaningless acronyms in the thing. Long-term evolution doesn't give you any clue what it is, but it's the standard that can supposedly go up to, I think, 100 megabits per second and perhaps even further. And people say it's very good. And this is what's really deployed all around the country. And you'll see it. I see it on my iPad all the time. I can have LTE. I often have to turn it off to get a better signal. There is LTE a lot of places, but a lot of places the LTE signal is very weak. and the 3G signal is stronger, so I actually get better results used by turning it off. But when it's working, it's faster. And so here's a summary of most of those standards. The very newest ones are missing from here. This came from your book. All right. I got a few cahoots about wireless. Let me bring them up here, which is log in, my cahoots, and there it is. All right. All right.
Thanksgiving flare up now.
What?
There's some Thanksgiving.
Oh, yeah, that's right. They got rid of the creepy music. Yeah. Well, they're sure having a lot of fun. I don't know how they're making any money.
Well, there's no ads or anything.
There's no ads or anything. That's why. There's not even trying to get me to pay more for some kind of premium version. I don't understand why this exists. But I'm glad it's there while it is. I'm keeping a separate copy of all the questions because this could be gone tomorrow. What's that?
Maybe that's something that they're analyzing. Since this is education, they're analyzing the questions. Yeah, the questions being used.
I don't know. Somebody would have to give a grant. Anyway, I guess I'll wait another 5 seconds to see if any more people are coming. Did the textbook company start?
I'm just,
I don't. I'm just an American. I don't understand how anything can exist if there's no money coming. It just violates my concept of being Irish. Anyway, so. All right, so what's the name of the wireless network? All right, that's the SSID, service set identifier. Which one goes 11 megs? Yes, good old 802.11b, the first big hit. Which one goes to 7,000? That's AD, the very latest one. All right, which one only goes 10 meters? All right, that's Bluetooth. Familiar. All right, which one has been abandoned? That's WiMAX. Someone told me the Space Needle in Seattle is a WiMAX tower. Anyway, this happens a lot. People invest in stuff and then it's gone after a while. William. Han. And E is Eric, I think. Okay, and Just a City Boy, I don't know. That's you. Good. Okay, good. You can tell me. Good. Good. And E might be Eric something. Let's see. I have a chat message. E, Eric. Yeah. Okay.
Yes.
All right.
Yes, it is I.
All right. So
It is I.
I guess we've got, we're not too far along. We can carry on here. All right. So here's, Tim comes and talks about this. Remember, this is something that he pointed out in his talk, is that Microsoft is kind of falling off the edge of the world here. Windows devices don't even reach 10% of the traffic on our wireless network or anybody else's. This is why Microsoft was very, very worried. They have totally failed to make the transition to portable devices like phones and tablets. And I don't see them making any inroads in that. They've been trying for like 8 years to do this. Just like Google's been trying for 10 years to make a social network, because they are very, very concerned that all the content worth seeing might be on Facebook and they won't be able to index it. But both of them cannot figure out how to do it. Somehow it's outside the competency of their company. stuck in their niches. And Unix and Linux did win. It just wasn't free Unix and Linux. When it was proprietary Unix and Linux that run in the form of iOS and Android, which is proprietary but open source anyway. But it is free.
The iPod is on there?
Yes, the iPad and the iPod. The iPod is down at 4%. Yep, that was 2013. Probably less by now. Yeah. Anyway, so you can view these things in monitor mode. Let me see if I can do it. I think I did it before, but this is a good thing to see. If I think it's gotten much easier in the very latest version of this. If I do capture options, it's now right up here. Here's an Ethernet network, and I can go here and turn on monitor mode, and which is much easier than it's ever been in the past. Yeah, and now I see those things I was telling you about: clear to send, request to send, block, beacon frames. All these things do not carry any data. These aren't even SYN and ACK packets. These are all the packets it has to send around to get ready to send a SYN and an ACK. And so, like, here's a beacon frame. Take a look at that. It's got a wireless LAN, and someplace down here, it's got all kinds of information about power and such. And somewhere it'll have the name of the network, county code, environment. I'm actually not seeing the name of network any in that one, so maybe that's a beacon frame of something that's not advertising its SSID. Let's see what other beacons we might have. Here's a request to send, a block. There's actually some data. Clear to send. Let's try sorting by this. Okay, now I got beacon frames. And again, nothing readable. Anyway, I'll try one more, see if I can find a different one. Here's one with a different length. And Microsoft, vendor-specific Microsoft stuff, all these parameters about what it's sending. CCSF student, okay, there it is. I thought this would be readable ASCII, but apparently I'm wrong. The CCSF student is here. Oh, there it is, it's up here, or that's not where I expected it to be. Good. Sorry, that's the readable beacon frame. That's the CCSF student network broadcasting with many, many parameters, and that's the point. The beacon frame tells you what channel it is, what kind of encryption it is, and so on, so your device can decide whether you can join or not. And it's used by your operating system to prepare this list and to put these icons on it so you know what's available. Anyway, that's the, you can sniff in this mode, but in this mode you can't see TCP or UDP packets, and you've got a project where you catch this stuff and crack into the encryption of WPA2 networks by catching the 4 EA policy statements. Anyway, so now you've got some new security risks. Authentication determines whether people are allowed to connect to the network. If you have a wired network, you can just know what computers are attached. But in a wireless network, anybody might be picking up a signal either by sneaking into your building or by sitting outside with a big antenna up to a mile away. I think the farthest, DEF CON, they had a stunt to see how far they could send a Wi-Fi signal. I think they sent it like 54 miles with a pickup truck and an antenna 6 feet across in 2 mountains from point to point. In principle, it's going through the whole universe. So you have to have some way to decide whether people are authorized to connect or not. 802.1x is the gold standard of this. This is where everybody gets their own password, their own secret, and you can change it. You can add new people and remove people without having to kick everybody off. So this is the point. And it has a variety of ways to authenticate using these different protocols. PPP is what's commonly used for internet service providers for things like DSL lines. It's just a way to authenticate who you have at the other end of one cable, point-to-point protocol. It's not intended to solve the broadcast or multicast problem where you have many people sharing a line. It's just a serial cable from point to point. So you can send it with PAP, where you just send the password in plain text over the wire with no encryption, which was the earliest and simplest method. And it was appropriate when you were just authenticating between devices in your own company from here to there. But once you're going over the internet, this is no longer a good idea because you are in fact passing over shared lines and someone can intercept it. So next step up was CHAP, Challenge Handshake Protocol, where instead of sending the password over the wire, you send a challenge, like a few random characters. You add that to the password and hash it, and then send the hash over the network. So the thing that goes over the network proves that you know the password, but you don't send the password directly over the network. Now the problem is, a man in the middle can totally defeat that. And if the hash routine is not very strong, people can in fact calculate millions of hashes and make a dictionary and deduce your password that way. So there's a series of vulnerabilities that limit CHAP and MS CHAP and MS CHAP version 2 as it went through various improvements. All of them are not very safe, and you crack into some of them in the projects with a sleep. So EAP was the enhancement to move to a variety of authentication methods, some of which are much better. You can now use certificates on one or both ends. Digital certificates can be almost perfect. If you use a short key, they can still be hacked, but if you use a modern key like 2048 bits or more, then they are very, very secure, very hard to forge, and very reliable. And then there's Kerberos, which is MIT's method used by Microsoft domain controllers to pass tickets around the network that give you permission to access a resource but are not directly connected to your password, sort of like CHAP, but it's better than CHAP, considered more secure. And then the main identity card in this world is an X509 certificate. That's the protocol here, and that's what is used on the internet to identify servers. You can also identify people, and now that there are free providers, people could have their own personal X509 certificate, but it's not a very popular thing to do. It would be much more secure, but then you'd have a problem handling the certificate. You'd have to somehow carry it around with you on a USB stick or something and put it in every device you use. And most people are still preferring to use passwords, which they remember and type into every device they use, which is much less secure, but it is the currently traditional way to do it. So here's how it looks. Your X509 certificate, let's bring up a real one. Here is Kahoot. Let's look up Kahoot's certificate. So this is a secure connection. Your information is private. So if I learn more, it'll tell me more about it. That's not what I wanted. I want to see the certificate. And where the heck is it? Site settings? Well, maybe Chrome has moved this stuff to where I can't find it. Do you guys know where it is? So I click this. It used to just show me the certificate. Now it just wastes my time. All right, let's try Firefox. Where have they hidden the blooming certificate? Okay, here's Mozilla. If I click on that in Firefox, secure connection, and right here is more information. Here's the certificate. Okay, I don't know where Chrome has hidden it, but it's in Firefox, it's here where it used to be. So I can view the certificate right here. So this is the summary of it. The certificate proves that I'm really talking to Mozilla. It was verified by DigiCert, and this certificate proves who they are and is valid until a year from now. I can view the certificate here, and this gets me down to what it is. Your certificate has the name of the company and a serial number, then the name of the company that issued it, and it has fingerprints, SHA-256 and SHA-1 fingerprints these days, which is good. People are getting punished for using MD5 these days. And here's the hierarchy. Why do I believe that this is Mozilla? I believe it because DigiCert said they are. Why do I believe DigiCert SHA-2 said they are? Why do I believe them? I believe them because these people said they were, and those people are built into my browser as trusted certificate authorities. About 100 companies are. They're included in the browser when you install it, and anything they say you accept as the word of God. That is the current system. And they are all treated equally trustworthy, and that worries a lot of people for a lot of good reasons, because some of them are pretty dodgy, like the government of China is an accepted certificate authority. Anything China said, you believe it's true. Because if you didn't, nobody in China could surf the internet with that browser. Now, Americans might probably not like to not believe what China says as much as someone else, but there's currently no common system that lets you rate these people in terms of how secure they are. Chrome protects you with extra non-standard options. Chrome knows who should have signed the top 1,000 sites. And if you get a certificate from someone that shouldn't have signed it, it will warn you. That is not a standard protocol, but it's an option there. Anyway, that thing is called an X509 certificate. And it's the standard thing here. And the main point of that certificate is to deliver a public key. First, it verifies who you're talking to, and then it gives you a public key. And here's the public key for this one. And now you can scramble any data with that public key, and no one on earth can read it except the holder of that certificate, assuming that they haven't managed to fool you or your browser, and you really got it validated from the right certificate authority, and assuming the certificate authority didn't let anyone hack them or bribe them to hand out the root key, and assuming the company at the end did not let anybody hack them or bribe them to hand out their private key. Nothing is ever perfect, but if everyone is being honest, you have enormously high assurance that all your data is going to the intended person and they're the only one who can read it. So A lightweight extensible authentication protocol, as I mentioned, WEP came out, wide equivalent privacy, and it was rapidly proven to be unsafe. And the IEEE did not have any safer standard for years. So manufacturers all made their own proprietary improvements on WEP. Cisco's version was called LEAP, Lightweight Extensible Authentication Protocol, intending to be safer than WEP. And this guy, Joshua Wright, a well-known wireless hacker, figured out how to hack it with an offline dictionary attack and wrote the tool called SLEEP. And this is the common reaction when you write a hacking tool. These guys got very upset and said, here he is just making trouble. This was Microsoft's position at the time too. They said, what hackers should do is just shut up and not tell anybody about the vulnerabilities, and then everything will be fine. We will continue selling vulnerable crap to everyone. They will use it and everything will be fine because the people smart enough to hack into it will just shut up. This is an interesting model of human behavior, not in much accordance with reality. And but this rests on a really popular myth that you have to be a super genius to be a hacker. And if you think of it, oh, no one else in Russia or China or North Korea or anything is ever going to figure it out. You're the only one very smart enough to figure this out. This is not a very smart perception. There's a lot of really smart adversaries out there. So by the time one of us white-haired hackers figures something out, you can probably assume the criminals have already got it. At least I think that's a much more realistic plan, so it's better to publish it so people know. Anyway, they got very upset about this. They called these guys narcissistic vulnerability pimps for releasing secrets. And so these guys got T-shirts that said narcissistic vulnerability pimp and wore it around everywhere. That's the best thing to do when people insult you is put it on a T-shirt. I've been doing that for years. Anyway, so it's an issue. And this is the whole full disclosure thing. A certain number of people just go straight to the press. The current fashionable trend is to go to the vendor and give them some period of time, like a month or 3 months, and then go to the press. That way you don't get accused of being a cowboy. It's hard to say. This goes on backward and forward all the time, whether you should really just release vulnerabilities or not. Anyway, so LEAP was not that secure. It was hacked by that tool, but ETLS is quite good. This is one that requires certificates at both ends, signed by certificate authority. So it's expensive, but as you might hope, it's really quite secure after you do all that. Microsoft PEAT and Protected EAT are also considered very good, and they only require a certificate at the server end, which is what a lot of people do anyway. So these are other things you might use at a company. Anyway, here's how 802.1x works. You have a supplicant, which is the user trying to connect with their phone or laptop or something. Then they have an authenticator and an authentication server. So the supplicant connects to the access point, which is the authenticator, and says, I want to connect to the corporate network. It says, okay, before you do that, send me some credentials. Then it will send those credentials up to the server, which will decide if you're on the approved list. And if you are, then you can connect to the corporate network. And if not, then you can't. That's how it works. This is not popular for home users and small businesses because you have to pay for another server. Just like you have to pay for a domain controller to have a Windows domain, you have to pay for a Radius server to have the 802.1x. The advantage is now everybody connects with different credentials, which is a lot better than the home version, which is called pre-shared key, where you have some password and you type the same password in every device. The problem with that is that everybody knows the same password, so if one person can connect, all of them can connect, and if you want to fire somebody and kick them out, you have to change the password and affect everybody else. Here you have everyone has a separate password, so you can remove one person, add a new person, force them to change it and not make them all change it, and the stuff you really need to do in corporate network. All right, so wide equivalent privacy was the original one. It had many vulnerabilities. I used to give it to students to crack it for homework, but I quit because WEP is so rare, it's not that important anymore. Just know that it's not very safe, and if anybody's using WEP, you can crack in usually 5 to 10 minutes with a normal laptop if you get the right card. One of these special cards lets you have rejection limit. Wi-Fi protected access was expected to be a short-term emergency improvement on WEP just to tide us over a few years until we got to WPA2, and it turned out to be much, much better. Nothing serious was ever found to be wrong with WPA, and it's still secure today. The only thing about it is WPA2 is actually faster on modern hardware, but there's nothing really wrong with it. It added 4 things to fix the specific vulnerabilities in WEP, one of them being temporal key integrity protocol. The way you crack WEP is you send thousands of packets to the server until you get about 50,000 packets all encrypted with the same key. And then you compare them mathematically. You can do something about the key, and then you only have a small key space remaining to search. That's how you crack WEP. You don't have to try all possible keys. By getting many packets encrypted with the same key, you can eliminate a large category of keys. So temporal key integrity protocol just keeps changing the key for every packet. So you can't accumulate a bunch of them all with the same key. That turns out to be a very good trick. That turns out to really slow things down. It has these other things too, a message integrity check, so that you cannot forge packets. You can't just play a duplicate of a previous packet. Each packet has to have sort of changing hash value that you can't predict. So that's another way you make web crack faster, is you keep replaying an old packet over and over and over to make it encrypt the same packet 50,000 times. So you get a chosen plain text attack, essentially, which makes it possible to do something about the key. There's an initialization vector, and they made it longer. There's something called per packet key mixing, so that keys used for one client are not used for the next client. They're different. And a rekeying mechanism. So these are all things that made it stronger. They're all included in WPA. And it turned out people were afraid that although these 4 vulnerabilities were found, even if you patched them, there might be another 4 vulnerabilities, but that did not happen. After you patched these 4 things, nobody found a way to break in anymore, and WPA remained quite fine. WPA also has 2 modes. It has the pre-shared key mode that people use at home, where you just type in the same key in every device, and it has the enterprise mode, 802.1x, where you add a radius server, and everybody has a different key. They can both WPA and WPA2 have those options. Rep did not have those options. So, like I say, WPA, in principle, does not implement all the security features, but it turns out to be okay. And so I mentioned this pre-shared key is what you use in low security or home environments, where you type the same key in everywhere. At a company, you use 802.1x, which is better, but requires you to have a server and maintain a whole database of credentials. There have been a few flaws in WPA found. In 2008 and 2009, people found ways to inject packets for a period of time up to 18 minutes, but it didn't turn out that they could do the other steps necessary to really crack it. But there are a few things you can do with WPA that you really shouldn't be able to do, but none of them actually reach the point of getting you in without the key. WPS, however, ruined everything. Around, I think, 2004 or 5, I started seeing this in Microsoft manuals. WPS was an attempt to make it easy to configure WPA. See, most people I know have simple things like just the name of their country or language or something for the WPA password, which is, of course, not secure because anybody can guess it. So the idea here was it will automatically generate a WPA and automatically send it from point to point. Put a button on the router or a button on the NIC, you press the button and it sends the key around so the humans don't have to remember the key, which sounds good. But what happened is, in order to make it easier, they take any passphrase you type, as long as you want, and they boil it down to an 8-digit number and use that for the key. And the 8-digit number is not even an 8-digit number. It is a 4-digit number. And then a 3-digit number, and the last one is a checksum calculated from the others. So the actual number of possible combinations is 10,500. That's it. And so you could just try them all. And this is what the Reaver attack does. This is me doing it at home. It took about 19 hours to hack in. It just has to try all of them. Now, this turns out to be more secure than you might think for 2 reasons. Most manufacturers I found that make home routers are smart enough that even without the benefit of an official IEEE statement or anything, they took a look at that thing with 8 numbers and they said, that's not long enough. So they put in a proprietary ad hoc solution, like if you guess 10 times, it locks you out. The other thing is, I found that most routers that cost less than 150 bucks are built so badly that they crash after 10 or 20 guesses and reboot. That slows you down, and it also means that the customer is losing service, so they would probably notice. But if someone was willing to just keep rebooting the router for 19 hours without figuring out something wrong, then you can eventually get in, or if you pay for a $150 enterprise class router that can actually withstand the attack. That's the joy of WPS. It was Wi-Fi protected setup. And I think Cisco wins the king of stupidity here. If you buy Cisco devices, they have WPS, and you can go in the configuration menu and turn off WPS. And if you do that, you can't use it anymore, but this attack still works, which is rude. They leave it functional enough to break in, but not for you to get any benefit from it. This is why some people say they're happier to put on Linux firmware at home, like WRT, because that never supported WPS and they never wrote it in anyway. So anyway, if you have WPS, you should be aware that you should turn it off or activate some proprietary feature to lock you out after 10 guesses or something, because it's obviously unsafe. Yeah.
So this might be very off topic, but when you turn on a hot zone on your phone,
Yeah.
how does it work in terms of a router?
When you turn on shared internet connection on your iPhone, it automatically has WPA or WPA2 for the passcode. And anybody with that code connect and share your internet connection. And it acts like a router. It hands out network address translation addresses. But it seems perfectly fine. And I don't think it supports WPS right now. I've never seen that on it, although I haven't tested it. This seems okay. Anyway, so war driving is how you find these wireless networks. Now they're just everywhere. But there's a time when you try to hunt for one and you hope to find an unencrypted one so you could use the internet. And so you drive around and find them. Technically, one could argue that if you park outside somebody's house and use their unencrypted Wi-Fi, you're breaking some kind of law, but no one's ever been prosecuted for that. This is one of those minor things like doing an Nmap scan. It's very hard. No one's ever succeeded in jailing anybody for doing these minor things. It would seem to me like the damages would be 1% of my monthly internet bill or something. It'd be hard to see how you could get enough damage to be worth it above. Anyway, and people have done it with balloons and flying and trucks and bicycles and everything as they map it out. We did war driving in the past every semester, and we had the results here where you saw red is with WEP, and WEP used to be half the networks, and when it went down below 1%, I said, well, there's no real point war driving anymore, and there's no real point teaching people how to crack WEP anymore, because at least in the San Francisco Bay Area, WEP is a historical dinosaur. You're not going to see it very often. So even WPA2 is almost all of them now, the light green. These WPA devices and the web devices have pretty much just been thrown away and replaced by newer devices. I really don't think very many people are turning on better encryption. I think they're just buying newer devices that have better encryption by default. The blues are unencrypted, and that does not necessarily mean they're insecure. A lot of them are deliberately public, like a coffee house. And when you connect, they'll often send you to a portal that makes you put in a credit card number or something. So it's by design that they're unencrypted. It doesn't mean that they're exposing some information they shouldn't be exposing. Now, a couple of weeks ago or a couple of months ago, there was a big scare about WPA2. Somebody found a way to supposedly connect to WPA2, although they wouldn't give the details. It's a large number of devices, had some random numbers that weren't random enough, or something like that. They were able to predict some numbers and break into WPA2 and lower it to the security of an unencrypted wireless network. This is a thing to know. However, I should mention, I don't know why people got so excited about this, because nobody should be trusting wireless encryption to protect you very much anyway, because as soon as it hits the router, it goes into wired networks and it's not encrypted. So the only thing the wireless encryption does is stop people from stealing near you in the coffee house on radio. And it doesn't do that very well, as you'll see if you do the projects. WPA2, you could sniff somebody else's WPA2 traffic. You could do it on a city college network by getting all 4 EA Paul packets. So it never really did even protect you that much from people sitting next to you. The only thing it does is if you have a password required to connect, people without the password can't get in. That's about all it does. But if you actually want to send any data that's sensitive, like a credit card number or a password, you should have a higher level encryption protocol like HTTPS, which means that even if they get into traffic, they can't see it. I don't understand why people thought wireless was protected them that much anyway, wireless encryption. The only real thing it does is stop your neighbor from using up all your bandwidth downloading Bitcoin, because they don't have your WPA2 password, and that, as far as I know, is still true. If you don't have the password, you really can't get in. Anyway, so you just drive around with an antenna, you record all the packets you go by, mostly you pick up those beacon frames and see what's advertised and how strong it is, and then map them out. NetStumbler was the early tool used by a lot of people to find open access points. After that, I switched to using something called this Stumbler, which works better on Windows. Kismet is a powerful tool. You'll find it in Linux. It's a little bit hard to use, but it sniffs wireless traffic and gives you a lot of information about it. And it's considered the most powerful war driving tool. It can do other kinds of analysis. It can detect hidden SSIDs, even if you don't broadcast the SSID in the beacon frames. It's in the packets, and if people are sending data, you can pick it out, and Kismet will find it. So if you do find a wireless network, and then you have to connect somehow by getting in, by either finding a web network or an unencrypted network you can connect, or by guessing the WPA key. And once you've connected, then it's the same as any other hacking. Now you've got port scans and using things like Metasploit to get in. So AirCrack NG is the main web cracking tool. It's included in Corley, but like I say, web cracking is a historical artifact. Wi-Fi pineapples are quite popular. Buy a special router and automatically runs a whole bunch of these attacks. One of the things it does is yaw sender. It has a, when you boot up your device, especially Apple devices, it tries to connect to its previous network. It says, am I at work? Am I at home? If so, connect me right in. So it broadcasts the name of the network it wants to see. Are you out there? So this will listen to that and say yes. So if you go to DEF CON or something, you'll find that the in-flight Wi-Fi is there, Microsoft corporate Wi-Fi, Google corporate Wi-Fi. It claims to be everything. Every laptop which says, am I at Google? Says, why, yes, you're at Google. Am I at an airplane? Why, sure, you're on an airplane. Am I at home? Sure, you're at home. Connect right in. It tells you whatever you want to hear. And once you're in, it performs all these man-in-the-middle attacks to steal your passwords and everything. So these things are very popular. So the students have them. So if you don't want people finding your network, you can try lowering the power of the Wi-Fi antennas so not very much of it goes to the walls. You can put metal paint on the walls and metal film on the windows to try to keep the radio inside. You can put up honeypots that broadcast fake wireless networks to confuse people. That's not very popular because they create interference for your normal ones. There's a variety of these techniques. All right. WEP has two versions, 104 as opposed to 40 bits. They're both worthless. One thing you should know is however you secure your wireless network, it's never going to be very secure. So you don't put it in the trusted internal network. You put it in the DMZ where your semi-trusted stuff is like your web server and your email server, which you know are likely to get hacked. Your wireless network is also likely to get hacked. So anybody connecting from the wireless network should be treated with suspicion and forced to go through another authentication step before they get at your real crown jewels. MAC address filtering is a common technique people use. It's kind of handy if you're at home just to stop your neighbor from using up your bandwidth. It's kind of pointless for anyone serious because your MAC address is transmitted in plain text in every packet you send. So anybody can just sniff with Wireshark and find the right MAC address to connect if your network is unencrypted. But if you want to defeat it, all you have to do is change your MAC address, and that takes one ifconfig on Linux. And in Windows, it just takes going into Device Manager and going into the properties of the wireless card, and you can change the MAC address right there. MAC address is burned into the firmware of your network card, but that address is not used. What happens is during boot up, that address is copied to memory, like the registry in Windows, and that's what's used. And you can later override it and have a different MAC address. This is handy if you want to go to the airport and they only give you 30 minutes of Wi-Fi. All you have to do is change your MAC address every 30 minutes. You get another 30 minutes of Wi-Fi, which is another one of those things that is probably technically some kind of fraud, but in fact the damages are so small it's not prosecutable. It's like using somebody's wireless network without permission. Maybe you ought to charge me $50 a month for an internet, so if I get an extra half hour, that's what, 10 cents of fraud right there. So anyway. Some more Kahoots.
I looked it up. They do have a previous version of course, they try to sell
Kahoot does?
training.
Oh, cool. Yeah. Okay. Well, I guess that's how they're making their money.
Seems like the main feature is you can stick your logo on it.
Oh, okay. Well, all right. Well, I hope those guys are enjoying paying for that. I don't know, man. I sure get a lot of value out of it. I hope they stay in business.
Really?
If they charge some reasonable amount of money, I might even pay it. I paid something to Zoom finally.
It's a 30-day free trial.
Oh, maybe I should check it out. Yeah. Thank you. Anyway, try these. I'm not sure what feature they could add that would make me want it more, but maybe they can think of something. Yeah, I forgot to mute the people, but I don't think they've been annoying each other too much. On the CCDC call, people forgot to turn off their speakers. You could hear them like saying things they didn't want other people to hear. This is like when broadcasters forget the mic is live. Reagan did that one time. He said, you always launched the nukes to Russia. Didn't know the mic was live. Give it another 5 seconds. All right. 5 questions. So which protocol sends passwords in plain text? Which is obviously a terrible thing to do. All right, that's Pat. Password authentication protocol. So what's the digital certificate format? Okay, X509. I don't know why in the world it's called X509, but that's what it is. I don't think there were 500 things before. What's the security measure to patch web? All right, TKIP was specifically a security measure. LEAP is actually not a bad answer. I should have moved it from there, but I think TKIP is a slightly better answer. TKIP is the actual security measure. LEAP was Cisco's proprietary attempt to do the same thing. I try not to have things that similar on there. That's a cruel question. The good thing is extra credit. Please don't hurt me. All right, so what protocol requires an authentication server? All right, that's 8021X. The alternative is PSK, where you don't have an authentication server and everybody uses the same key. This is the home version. This is the enterprise version of wireless security. All right, and what's the protocol that's vulnerable to a simple brute force attack? WPS is the problem. WEP is not a simple brute force attack. That's why people thought it was okay. The key can be 128 bits. If you really had to try all of them, you'd never be able to try them all. There's a mathematical flaw, so you don't have to try them all. But WPS only has 10,500 possible keys, so you can just literally try them all. That's the problem. All right, so it's E, it's 6, tip. I remember who tip is. He's 3, and Mustafa, I know who that is. All right, so, all right, the only person who has to tell me who City Boy is, I'll find out at the end. There's one thing I want to show you, other than this lecture, which is the new project I spent the last day and a half writing. At this call that I was talking about from CCDC, the defense competition, they had a guy from the red team talking about what people did wrong, and that was interesting. And what he said was, let me just introduce you to this competition for a minute. Here's what the cyber defense competition looks like. This is the network that was used at the last national network. So you have a network of machines you're controlling. They're virtual machines like this. So you have a DNS server, and this is an HTTPS server, DNS server, email server. Here you have a web server. Here's your domain controller. There's a workstation, and then there's a firewall up there someplace. DVIOS is a firewall. So this is a typical small business network with 5 or 6 servers and a firewall. And one of the security measures that you ought to do, which you're complaining people didn't do, is your first thing ought to be to go to the firewall. And if this thing is only serving SSH, SMTP, and POP3, you should block all of the ports. So no traffic comes to it except on the ports you're using. That's rule 1. That'll stop a whole bunch of attacks. And he said people weren't doing that. So it occurred to me, there's no easy way to practice that, so I'm writing it. So you can start doing it if you want to. This is a good skill. You should learn how to configure firewalls. So I wrote a version of a project called Firewall Hero. This is hopefully intending to be kind of like a game, although as you'll notice, I lack the aesthetic part. I need an artistic partner to make the game fun. But the point of this thing is you can practice configuring firewalls, and it'll work on any network. So I wrote this stuff in Python. It runs on any operating system. So let me show it to you. Here's what you have to do. Install Python. If you have Mac or Linux, it's already there. If you have Windows, you have to install it, but it'll run. Then you download this zip file and unzip it, and that includes software. And what this software will do is listen on 28 ports. So I can tell if the packets are getting through or not. So let me start it here. Looks like I'm missing an image, but such is life. Here I am. Here's the software that I wrote, and the listen.py is what listens on every network. So if I do sudo listen, you give a password, All right, it gives me a whole bunch of address in use errors because I'm already running and I haven't rebooted my machine since I ran it. Now, if you have a Linux machine, I actually made something to kill it in case this bothers you. If you have Windows, you just have to restart your machine until I figure out how to write the same thing in Windows. That'll kill them all. Those are the 28 processes. And now I can start them again. So now it's got 28 listening processes. Now, this is what you have to do. Once you've got that working, the next thing that worries me is you might be behind NAT. Almost everybody is. And if you're behind network address translation, even if you're listening, nobody can send anything to you. You'd have to configure port forwarding on the router, and most of us are behind coffee houses or company networks where we can't do that. So you need a VPN. So I put a VPN server up you can connect to. And in that zip file, there is a client.ovpn. This is a VPN configuration file. And you can run it with OpenVPN, which is free software that runs on any platform. The version I'm using on the Mac is the popular version called TunnelBlick. So you connect to the VPN, and I was discussing this last night with Kurt, and he pointed out to me how to get past the City College firewall. City College blocks OpenVPN. So we just moved it to port 53, and that fooled it. It looks like DNS. So our firewall seems to be so stupid, it's not using layer 7, it's just blocking at layer 4 by port number, which I appreciate, because now I can connect. When you connect with a VPN, what happens is, it's as if I'm connected to a local area network. If I do ifconfig, I now have a network called UTUN. There it is. This is my tunnel network, UTUN 0. On Windows, it's called something else. But it's now, you see, it's a point-to-point network, 10802. It should be, so now if I ping 10801, I get a reply, and it's only one hop away. I now have an encrypted tunnel directly to my server. So I can now be probed by the server. So what you have to do is now view this page through the VPN. Notice this is attack.samsclass.info, going over HTTPS. But once your VPN's working, you can connect to it directly with 10801. And that's important because I need the direct contact to do a port probe. So now that you've got that working, then you test your system here. And this will do a port scan on my system, and it's doing a port scan on all these ports and finding that 2 of them are blocked. That's because I was testing it before class and I left my firewall running. So I'm going to turn off my firewall, which is this. Now I should pass this test. Let me refresh this page. And now I passed the test. All 28 of these ports are running my service, returning what it expects. So my system is ready. So when my system is ready, I can now do the challenges. I only have one, but now that I got this one working, the others will come pretty quickly, at least a few of them. So here's the challenge. It tells you block these ports. And when you're ready, put your name here and click it there. So to block these ports, you have to figure out how to do it on your system. Now on the Mac, there is a graphical firewall that you cannot control in any detail at all. On Windows, it's pretty easy to control it. And the Mac, you have to use the command line. And so what you actually have to do on the Mac is modify this file here, this one, pf.conf. And what you do is you block them down here with these configuration commands, block in quick proto if any port number. So I want to block 520 and 6000. So I block 520 and 6000. And this is going to make sure that I block them, but nothing else. So I put in the configuration file to block them. I start the firewall, which is that one. PF is now enabled. Now I should pass. And I pass. So now I end up on a winner's page. There. And so I'm going to assign, probably anybody wants to do this can get extra credit for it. It is worth learning how to configure various firewalls. There are a lot of firewalls out there. Linux, Mac, and Windows is a start, Windows Server, and then all the routers and everything. Any kind of firewall will do, and I'm going to have more of these. The things I want to do after this to get closer and closer to the real contest, one of them is to make you do faster. That's obvious, with more ports and faster, so you get good at it. The next thing is to make it so I don't tell you what ports are in use. Instead, for 5 minutes, customers are using it, no bad guys are attacking you. You have to deduce what ports are in use and block anything new that comes in. That's how the contest works. And there's more I want to do after that. I want to then move forward. The other thing he pointed out is people are not watching their authentication logs. So you should know who should be authenticated, and when someone else authenticates, just kick them out. And you should also know when unexpected TCP connections are made and just disconnect them. So I'm going to have more versions of this to get my CCDC team practicing how to monitor the state of a server and notice when a bad thing happens and kick them off. Yeah.
So with this, I'm thinking of a DDoS. Would this server be able to handle multiple people accessing firewalls?
Yes. The server I'm running here is listening to all those ports, and there could be a lot of people coming in. There'll be some limit to the amount of traffic before it can't handle it anymore. But that's just a question of your bandwidth and your server power. And in fact, in the CCDC contest, the servers are very underpowered. They can't handle much traffic because they're running, 20 teams. Each of them has 10 virtual machines, and they're running with minimum configurations. But at companies, of course, they run bigger things and can handle more. DDoS is another issue. In fact, that'd be another thing to try. DDoSes are where you're getting bad traffic, and you have to figure out how to block it and let the good traffic through. So you have to find some kind of pattern of the bad traffic that distinguishes it from good traffic. That would be another good thing to make games on. But that's not relevant to CCDC. They don't do that. But it is important in the real world.
Yeah, a question.
I saw there was one up here. There it is, a chat. This would be an excellent project for 122. Oh, that's possible, but I'm not teaching that class. You'd have to pass that through someone else. Anyway, but it is going to be in 140 and probably in other classes this semester. As I make more versions of this, I'd like people to try it out and see what happens. On Windows, this does work. You have to run a different version of the software. So I'm going to point out, I'm going to make information here. I made a hints. And so I'm collecting a page with some information. Up here, I put the information about how to control the Mac firewall. And I'm going to put some stuff here about other operating systems as I accumulate it. If you do this on Windows, notice that you have to run you need a different OpenVPN client. And I did put a link where to get it. Yeah, here's where you get the Windows client. And you connect. And then when you run it up here, you have to run a different file. Yeah, for Windows, this file is wrong. I got the wrong picture there. Anyway, for Windows, you got to run listen win. I got to update both of these pictures. I just got this working today, so it's in a very rough state. But I made a different thing called listen win, which is not here, but anyway, that's what you have to run on Windows. The command line to run these is different on Windows. And the command line to kill them is different on Windows, and I haven't figured that out yet. So as far as I know, the only practical way to turn this junk off is to restart your machine. Anyway, I'll continue to update this with more challenges, but I think it is a missing part of our education to practice these defensive strategies. In general, I should mention, in case I haven't before in this class, the reason we start with hacking is because attack is much, much easier than defense. I've been doing this about 10 years, and now I'm beginning to break into teaching defense. Defense is much tougher. It's more complicated, and it is more boring and more difficult. It's a lot of hard work in defense. But of course, that's where all the jobs are, is in defense. And so it's good to learn. And the CCDC contest is very respected by employers. That is what you're really going to be doing on the job, running a network, trying to deal with people that are hacking into it, and management demands, and normal failures of all the software and hardware. And that's what a normal day is, running a real network. And they need people that practice that are in high demand. Anyway, any questions about anything? Yeah.
I've been reading articles recently about stingrays, like the police departments buying stingrays.
Sure.
And I guess those mirror our fake cellular towers.
Yes, they've been around for a long time. The stingrays are the police, law enforcement things that are fake cell towers, so cell phones connect, and now they're in the middle, and they can detect the cell phone traffic, and they can even downgrade it to weaker encryption they can crack and wiretap stuff. It's the equivalent of wiretaps for cell phones. But the laws around stingrays are very unclear, and they've often been deployed without search warrants. Just like putting bugs on your car have been deployed without search warrants, and in both cases, GPS trackers, and in both cases, the EFF and other people are vigorously arguing about when they should be allowed to do that. But I've been told you could put an Android app on your phone that will tell you when your stingray's around. You have a list of authentic towers and tells you when there's a fake one. And people tell me when you put that app on, it goes off all the time. So either that app is defective or the cops are using it like crazy. But the numbers I've seen have suggested that, in fact, cops are using this like crazy. They're using stingrays like crazy. They're using requests for data from your cell phone company to tell them where you were like crazy. And they're using GPS bugs on cars like crazy, because all three of these things are generally regarded to be usable without a search warrant. So they do not have to prove any high degree of suspicion to use them. So they're all considered ways of just saving police time. Instead of having a cop follow you, they put one of these electronic followers on you instead. And so I think it's happening a lot. And right now we're in the infancy of laws explaining when they can do it and exactly how much information they have to tell us about it. And the privacy people are, of course, quite upset and think they should be not using it so much, and they should be totally telling us every time they use it and how many times they use it.
So you said that they can potentially downgrade the encryption. So does that mean that 3G and 4G have some sort of encryption?
Yes, 3G and 4G are encrypted, and they're encrypted quite well with a secret 64-bit key, which is essentially uncrackable, what people tell me. So that's quite good, and it's not a shared network either. So if you were worried about these Wi-Fi attacks, the simplest thing is just use 3G or 4G, 5G, and you'll be a lot safer. But the Stingray gets in that.
Now, I've also NIST said that using dual authentication with SMS is actually insecure because SMS is not transmitted securely.
Yeah, that's certainly true.
So
the most common two-factor authentication uses an SMS. SMS is sent in plain text, so it would be fairly easy to intercept. However, the primary benefit of two-factor authentication is not that both techniques are secure. It's that if someone breaks in and steals a database of 1 million passwords, they can't use them because now they need to go steal 1 million SMSs and somehow correlate. A targeted attack, two-factor doesn't stop. The only thing it stops is these mass attacks. And that's why a second factor that's fairly weak, like a 4-digit PIN or your thumbprint or something, is generally considered good enough to make it a whole lot better than just a password. But it would be even better, of course, to have two secure things. But in practice, people are mostly okay with just a password, and they're trying to make a convenient way to make it more secure than a password. And a second factor that's not too strong is considered a big step up. But it would be safer if you want a safe alternative, use Google Authenticator, where you put an app on your phone, no signal is sent, it has a random number, it has a number that's created using an algorithm that's duplicated on your server. So now you have a number that did not get transmitted over any medium. That's safer. Or get an RSA token, which is just a hardware version of the same thing. So the options exist, but most people like SMS because then they can have a dumb phone or something. You don't steal a smartphone now, though. So, if you use Google Authenticator, you don't need the SMS version. All right. Any other questions? Well, I'll go to the last. Oh, you got one here.
So for the Wi-Fi Pineapple, have there been recent developments in the hardware? Have there been changes dramatically?
I'm not really sure. The Wi-Fi Pineapple, I think it comes from Hack 5. I think there's 2 or 3 versions of it, and I don't really know the difference. Some of my students have had them. They might be able to tell you. I know one version was hilariously hackable, and everyone was hacking the pineapples at DEF CON. I think it has a default password, and if you don't change it, then they're going to change it to just swear at you and throw away all the data and mock you for being an idiot. That's DEF CON. People will mock you for making insecure choices. Well, I'm going to stop the share and go to the lab and help anybody that wants help there.